This is Euclid Book 3, proposition number 2. Now the first thing we've done is we've drawn a circle just like this, okay? And we've taken two random points on it. Point A here, point B here. And what Euclid is saying is that if you draw a line between points A and B, it will fall inside the circle. And he says to prove this, what we're going to do is we're going to hypothesize that it fell outside the circle. Okay, so we've drawn this line A, E, B. And this particular line has been drawn outside the circle. Okay? Now, Euclid says that DA and DB are equal in length. Well, here's DA here, and here's DB here. The reason for this is that all radii of a circle are equal. Okay? Now, he also says that angle DAE is equal to DBE. Well, here's DAE, and here's DBE. Okay? DAE, DBE. These two angles are equal in size. And that's by Euclid Book 1, proposition number 5. Then he goes on to say that angle DEB is greater in size than DAE. Well, here's DAE. This angle here is greater in size than this angle here. Alright. And then he goes on to say that angle DAE is equal to DBE. Okay, so we already established that these two angles here are equal in size. Now that also means that angle DEB is greater in size than DBE. This one here is supposed to be greater in size than this one. Now that also means that by Euclid Book 1, proposition number 19, that DB here is greater in size than DE. This one here is greater in size than this one here. Alright, but the thing is that line DB and DF are equal in size. These two lines are equal in size. And that would mean that line DF is greater in size than DE. And as you can see for yourself, that's kind of stupid. So therefore, if you were to join a line between A and B, it would be found inside the circle, not outside the circle. And Euclid says by a similar proof, we can also show that the line between A and B would not be the circumference of the circle, but rather inside the circle. But you can do that for yourself. I will tell you more in a future video, so stay tuned.